Hello, everyone. My name is Mike Hosak, biologist with the Pennsylvania Fish and Boat Commission, co-chair of the Yellow Perch Task Group, along with my Canadian counterpart, Megan Ballore. Today we're going to be discussing yellow perch in Lake Erie. It's not quite the it's going to be quite the contrast from the talk we just heard about walleye, as you'll see. So, yellow perch in Lake Erie are managed using 4 spatial management units. Management Unit 1 through Management Unit 4 range from west to east. MU1 representing the West Basin, shallow and highly productive. MU2 and 3 comprise Central Basin with moderate depth and productivity. And MU4 represents the East Basin, which is deeper, colder, and less productive. These units reflect a west to east ecological gradient in Lake Erie, but with finer spatial resolution for management purposes. They also reflect ecological differences across the lake and allow managers to assess stock status and set harvest limits independently in each area. And it's important because yellow perch populations are not uniformly distributed throughout the lake, and they respond differently to environmental conditions and fishing pressure. So we'll begin with Management Unit 1. I hope you enjoy time series. All right. Okay, total harvest across all fisheries. Since all fisheries combined harvest millions of pounds on the y-axis, was about 1.45 million pounds in MU1, a 30% decline from 2024, accounting for about 63% of the TAC of 2.29 million pounds. So this is the Ontario gillnet commercial harvest and catch rate. So catch rate's on the other y-axis to the right in kilograms per kilometer of net, harvested millions of pounds. So in harvest is a combination of small and large mesh gillnets, but the harvest rate pertains only to targeted effort, so that's small mesh only. So the gillnet harvest in MU1 was 897,000 pounds, 24% down from the prior year. Effort was up 21%. The catch rate was down 39% from 2024. So this is the trap net harvest in Ohio waters of MU1, and the catch rate in kilograms per trap net lift. And the harvest in 2025 was about 260,000 pounds, 40% decline from the prior year. Effort was down 24%, and the catch rate was down 22% from the prior year. And moving on to sport harvest and catch rate in MU1. Here. So the harvest rate in these sport fishery plots, there'll be 3 others. It pertains only to fish that were targeted by anglers and not like indirectly caught in pursuit of other species like walleye or whatever. So the sport harvest in MU1 was 292,000 pounds, that 33% drop from the prior year. And the catch rate was down 29%, about 1.6 fish per hour. Okay, now moving on, this is assessment survey data. So we got 2 surveys here that are done every year, one in Canadian waters, the Ontario Partnership Gillnet Survey, and the Ohio Fall Trawl Survey. So beginning with the Ontario Partnership Survey, the dashed lines up represent their median, like long-term estimates. The median values, not means. The partnership values aren't not selectivity adjusted. So, excuse me here, I gotta pull this up so I can see my notes. You can see that in 2025 and in recent years, the survey indices are well below the time series medians. And actually the partnership percentile rank for 2025 was the 20th percentile. And for the Ohio Trawl Survey, 2025 was the 6th percentile in the time series. So we're seeing some declines in the survey data that correspond with the fishery data. Moving on to Management Unit 2, West Central Basin. Again, the same series of slides. So total harvest across all fisheries in Management Unit 2 was about 538,000 pounds, 53% increase from the prior year, although it was very low the prior year, so that 53% isn't that impressive. And the TAC was 972,000 pounds, so 55% of the TAC was harvested in 2025. This is the gillnet, commercial gillnet fishery in MU2. It's the same as before, harvest, small and large mesh combined. So the gillnet harvest in MU2 was 395,000 pounds, 60% up from the prior year. Effort was up 107%, and the catch rate was down 30% from the prior year, 2024. Trap net harvest and catch rate in MU2. Again, it's Ohio waters. The harvest was up 70% from the prior year. Effort was up 119%, but the catch rate was down 22% from the prior year. And most of this harvest occurs during the spring, so potentially it's they're harvesting fish that are aggregated at that time of year. So you might be seeing like an inflated catch rate from this particular data source. So sport harvest and catch rate, Management Unit 2. Sport fishery performance in Management Unit 2, as you can see, remains in a very depressed state in terms of harvest and catch rates. In fact, we're seeing some of the lowest harvests in the time series history in recent years. Effort, it's only 12,500 hours in the entire management unit, 61% drop from the prior year. Harvest being down 59% from the prior year, and the catch rate fell to 0.4 fish per hour, 55% drop. And so assessment survey data kind of shows a similar thing as the fishery dependent data. The same two data sources, just in Management Unit 2 now. So both surveys are very much below the long-term median, and the partnership percentile was only 11th percentile, whereas the Ohio trawl percentile was the 3rd percentile rank. So almost the lowest in the entire time series. Moving on to the East Central Basin, Management Unit 3. Same series of slides, some perch fun. So total harvest across all fisheries in MU3 was about 862,000 pounds out of a TAC of 2.1 million, leading to about 41% of the TAC harvested, which is quite low for this fishery. Moving on to gillnet harvest and catch rate, Management Unit 3. Gillnet harvest in MU3 was 656,000 pounds, 30% increase from the prior year. Effort was up 22%, but the catch rate fell 7% from 2024. And again, we're at nearly a time series lows for harvest and catch rate from the gillnet fishery, Management Unit 3. Looking at trap net harvest and catch rate. Again, these numbers look better relative to the other data in terms of like catch rate, but again, the fishery is occurring at a time of year when fish are aggregated. But so harvest coming from the trap net fishery in MU3 was 201,620 pounds, down 4% from the prior year. Effort was up 4%. Catch rate was down 8%. Looking at sport harvest and catch rate, and it really can't get any lower than it is in Management Unit 3. Unless it somehow went negative, which it can't. So sport harvest was 4,380 pounds, down 55%. Effort was down 65%, only 4,090 hours in all of Management Unit 3, and the catch rate was effectively 0. Now, it might not look like that, but that's a targeted catch rate, so that's for fish that were sought after effort, not just incidental effort or harvest. Survey data in MU3, again, the same surveys, trying to keep them consistent across management units comparison. Again, as we saw in MU2, it's the same situation pretty much throughout the Central Basin, well, throughout the Central Basin, that the populations are depressed, showing up in assessment survey data and fishery performance statistics. You'll see well below the time series median, some of the lowest values in the time series. In fact, the Ohio trawl percentile was the lowest in the time series, and the partnership survey, well, that also was the lowest value in the time series, so both were. Moving on to Management Unit 4. Last but not least, total harvest across all fisheries in MU4 was 308,000 pounds, 5% increase from the prior year. This represented a 64% of the TAC being harvested in 2025. Again, MU4 is performing stable to good moderate fishery performance in MU4, especially compared to Central Basin. Doesn't seem to be suffering from some of the issues that are occurring there. Gill net harvest catch rate in MU4. Gill net harvest was 254,000 pounds, a 2% increase. Effort was up 8%, and the catch rate was down 5% from 2024. So again, stable performance in MU4. Trap net harvest and catch rate in the East Basin. Trap net harvest was about 11,000 pounds, 5% drop from the prior year, and the catch rate was down 21% from the prior year. And sport harvest in MU4, the catch rate was actually 2.4 fish per hour, which is the highest we've seen throughout the lake. Again, 5% down from the prior year. Harvest was 43,000 pounds, a 29% increase from the prior year. And instead of the Ohio Fall Trawl Survey, now we're using the New York Gillnet Survey in the East Basin, obviously. So what you'll see is the values are at or above the time series medians for both. Partnership percentile rank was the 39th percentile, and the New York Gillnet Survey percentile rank was 63rd percentile. So things are looking okay in Management Unit 4. Okay, so normally we present data from, we present an RAH value derived from a statistical catch age analysis models that we run in all 4 management units, but this year marks a break from that, and I'll explain why. We're using approach this year referred to as a traffic light approach. I think it's also described in the literature. Will this work? Okay. So as I was saying, we usually estimate the recommended allowable harvest using assessment models and harvest control rules from our yellow perch management plan, but our current models are not producing reliable estimates. We're having issues with model convergence, retrospective patterns, where abundance estimates for a given cohort in a given year will change from year to year when new data is added to the model. And the models are also incorrectly estimating fishing rate at MSY. So there's just a lot of issues. We're in the process of working with the Quantitative Fisheries Center to develop new models. And but in the interim, we're using a traffic light approach to adjust the RAH up or down based on trends in assessment survey data and fishery dependent data. So this kind of describes the approach. It's color coded, just like a traffic light. So it uses survey and fishery dependent data sources. The data sets such as, let's say, gill net harvest. they're scaled such that when they're all averaged together, they contribute equal weight to the overall yearly estimates. And then percentiles are computed for each year, and they're ranked as low, moderate, and high. High being 75th percentile and above, moderate 25th to 75th percentile is yellow, and low will be red, below the 25th percentile. And based on these, based on where the percentile falls out, that determines what happens to RAH. It will be, adjusted according to that. So if the estimate turns out to be fall in the moderate category, there's no change. If it falls in the high category, you can increase the RAH, and if it falls in the below the 25th percentile, then the RAH should be lowered according to this approach. So this shows the results for each individual data source feeding into the traffic light approach. Now, all of these are going to be aggregated together to produce a single estimate, point estimate for each year for each management unit. But in this slide, you'll see where each individual survey or fishery summary kind of ranks. So the gillnet harvest rate, if we move from west to east from MU1 to MU4, I probably should explain every single cell here, but just looking, you can kind of get an idea of the performance across each management unit based on just the colors you see. Or the more red, the worse they're doing. So the yellow being stable, moderate, green being good. And the arrows just indicate the direction from the prior year. So what we can see are there issues. MU1, MU2, and MU3 are showing a lot of surveys that are ranking out low relative to their from 2025 relative to their time series, and MU4 is looking moderate to good, as we pretty much saw when we looked at the assessment data and the fishery results. Kind of get this aligns with that. And again, it's the same. Some of it's the same data. So, okay, this is what I was saying earlier, how they're all aggregated together and to create a point estimate for each year within each management unit. So you'll see the most important year to pay attention to, and this should do this. Is to look at the last year's estimate, the most recent year's estimate, because that's what's going to determine how the RAH should be adjusted. So for MU1, it ranked out in the 17th percentile, that's in the red category. So that would indicate that the tax should be lowered, or the RAH should. So in MU2, again, same thing in the red, 11th percentile. So you'd reduce the RAH. MU3, well, we were debating this in the pre-LC if that could even be called a percentile. 0%, 0. No. So, but yeah, it's as low as it can get, lowest in a time series. And MU4 ranks out in the moderate, 43rd percentile. And you see in MU1, 5 of the 6 last years ranked out in the low zone. And for MU2, 6 of the 7 prior years ranked in the low zone. And for MU3, the 2025, again, the lowest rank ever. And 5 of the last 7 years are in the low zone. And MU4, out of the last 7 years, 2 were good and 5 were moderate. So okay, so looking at 2025 only, management unit 1, 2, and 3 all rank in the less than the 25th percentile. Management unit 4 marks moderate. So based on the traffic light approach, RAH should be reduced in management units 1 through 3 and maintained in management unit 4 relative to the prior year, 2024 estimates. And just to bring a little bit of the state of the lake reporting into this presentation. So 21 to 2025, our objective is to maintain perch population, sustainable levels of adult biomass, and fisheries harvest consistent with the management plan for yellow perch. Now it's difficult to determine if we were meeting the biomass targets, because we did not run a stock assessment model. We couldn't. Well, we couldn't rely on the estimates. So we don't have biomass estimates or limit reference points for comparison with the management plan. However, despite this, we do have high confidence that for management units 2 and 3, we are not meeting our targets. And we have high confidence that we are meeting the target in MU4, and moderate confidence that we are not meeting targets for management unit 1. And again, if you're interested in the report, it can be found on the GLFC website where all the other task group reports are. And with that, I'll take any questions.